Great. Hi everyone. Sorry, Carson, I thought you would start up. First, can you hear me well? Please let me know. Right in chat. Um, all right, great. Okay, cool. So, hello everyone. Today I'm going to present a few caps, as many as time permits, and I have three total, and all of them were kind of spawned from Lee's proposal that is linked to one of the caps. And the idea behind the proposal was about extending auth capabilities for the classic star accounts or G accounts. And the idea behind it was to add a capability for a G account to have a set of contract signers, so one contract signer. And if you have a contract signer, you can really have arbitrary authentication logic, right? With arbitrary policies and stuff like that. But in addition to that, you could also add a capability to manage trust lanes, for example, from Soroban, which closes to more feature gaps because this proposal as it is, it won't be possible to use this C standards outside of Soroban because we currently do not provide a way to run contracts outside of the transaction apply flow. With that, like, Jay is not hearing me. I don't know, Jay. It seems like people still hear me. So that's kind of very high level motivation behind it. But I'd like to actually start with CAP 71, which is something I figured while thinking about how the whole G account customization thing could be implemented. And this CAP is about adding protocol level support for delegating authentication between custom accounts. Yeah, thanks, Marius. It's actually not a new mic, it's just Discord settings, which is funny. So CAP 71, and motivation for that stems from several different issues. And basically, currently, what is possible to do in Soroban, what some of you may know, there is this require auth function that requires authentication authorization from an address. And this function can actually be called from within a custom account check auth function that performs authentication as well. So this is kind of the current way of delegating auth. So you have an account, but instead of verifying some signature, you say, I trust this other contract to perform verification for me. And this has some benefits for like modular custom accounts. And it is like a cornerstone of this proposal for G accounts to have C signers because it's effectively the same kind of delegation, right? So instead of having a cryptographic signature for a G account, we say you don't actually know what the signature is. We let a contract to perform verification instead on its custom signature format. But this mechanism, while it kind of works, it was not like built as a full-fledged feature in the protocol. It's just a byproduct of the design. The design allows it, does not disallow it, because there's no reason to disallow it, but just kind of inconvenient to use and also not optimal to use. The inconvenience factor was mostly in simulation. So if anyone has tried it, they would quickly learn that you cannot simply simulate this. Currently, you need to build, for the delegated contract call, you need to build its own signature payload, which is kind of tricky. And this could, in theory, be fixed in the simulation layer. Although it might be a bit complicated as well. but yeah, it would still be kind of annoying because you would need to do several simulations in a row, kind of propagating more and more authentication information into the system. And yeah, I think it is still kind of annoying. But in terms of optimality as well, there is quite a bit of duplication here because like you spawn new authorization entries. Like for example, if you have two accounts and one delegates authentication to another one, then you would end up with two authorization entries in transaction that increases transaction size and increases complexity of building it. And the tipping point for me for why I came up with this cap is the context. Like some of the proposals that I've seen for the delegation for custom accounts maybe do not use context much. But if we were to do this for the G accounts, we do not want to lose the authorization context, which is basically the list of the contract codes that have been authorized. And the issue with the approach of call and require auth from within check auth is that you could pass context to the require auth call, but it would not look the same as the normal context that you would have during normal authorization, which means that, for example, let's say you have an account implementation that does something about the context. You cannot simply use it as a delegated signer of a G account, for example, because the context will be kind of in messy nested form. Like it will be an argument of a call instead of a list of the call. So it is kind of messy, and I think it is going to be quite annoying to maintain this mess in the protocol. Like it creates some inconsistency between like how different types of contract signers can be used, which is basically the motivation for this. But it also solves the issues I've described before. Oh yeah, and also if you want to have the context, you will need to attach it to the transaction as well, which is like even more duplication on top of what you have. Like besides like specifying multiple authorization entries for every address, you would need to specify like the whole call stack as well for every address, but in different forms. And it's a lot of mess. So what do I propose to do about this? It is actually not that big of a change, and it consists of basically two parts. One part of it is on the XDR side, as can be seen in the cap. And what we do in the XDR is we introduce a new type of credentials, which is basically this part of the authorization entry that contains signatures and stuff like that. And these credentials are pretty much same as Soroban credential of address, but they have an additional field called delegates, and each delegate is just a struct that contains an address and a signature is cval, which can be an arbitrary value that one can parse. And it also has a list of nested delegates in case if you call delegated accounts from within delegated account. And the cool thing about this XDR is that you may have a single authorization entry that has as many delegated signers as you need. So there is no duplication at all. Like there is only necessary information. So in the simplest case, for example, right, we have an account that asks another contract to perform auth on its behalf. And this will be represented as a single authorization entry that has the main account that we are performing auth for the credentials at the top level, and contract that actually performs auth and delegates array, and we only store its address and its signature. And this structure is very simple, and like if you get a result from this like it's usually up to you to fill in the credentials anyway. So if you are dealing with delegation as a wallet, what you need to do is just build this new type of credentials. It should be pretty simple. Like it's only a couple fields more than you would need to fill for normal auth entry, and there is no like this massive propagating the auth data into simulation and stuff like that. Is basically kind of a way to do multi-sig, but instead of doing multiple signatures, you have multiple like signer implementations on the high level. And there is one more small change which I will talk about a little bit later. And from the host side, we add two functions that actually allow contracts to interact with these delegated signers. The main function is delegate count auth, which is very similar to require auth, but it can only be called from within a custom account, so from within check auth reserve function, and it doesn't take any arguments. And what this does is something similar to require auth, but instead of like just authorizing the current call arguments and current call, instead it will inherit the context and the signature payload from the current checkauth implementation, from the current checkauth invocation. So basically, you have a checkauth, and then you have another contract that you want to perform checkauth for you, and that other contract will get exactly the same checkauth arguments and its own signature. Which is really cool. It allows like all the delegate signers to sign the same payload basically and have the same context, so there is no mess with like this nested context in arguments and stuff like that. So for every contract, it would look like as if they were authorizing the call themselves, while in fact they're doing this on someone else's behalf. And another function is just a getter of all the delegated signers present to the current auth check. And the motivation behind this function is simply that if we were to use this feature, you would have an issue of somehow attaching this delegated signers to your signature payload. Like you would need to list them in signatures or something like that. And like since I would imagine a few contracts would want to use this, and it's kind of annoying that everyone needs to re-implement this and come up with their own UDDs and stuff like that. And instead, since we already have the delegated signers XDR, we just add a getter that returns this delegated signers attached to the transaction and matched to the current call. So you can get them, and then you can make sure that they're actually the signers for the account, and then you call delegate account for them. So there is no need for some bespoke representation of these delegate signers. They're kind of built-in feature that you may use, and you don't need any data structure overhead. And again, this reduces duplication even further, because like if you fully delegate your auth to another account, you do not need the signature for your main account. All right, that's it on the high level for the host functions. The CAP has a bit more detailed description of the exact algorithm for how does it work, but I think the simple summary of it is really that it is require auth that just makes sure that the arguments look as if you've been authorizing the require auth call at the top level. And the last small thing that I've mentioned before in the XDR is that unfortunately we need a new type of signature payload, which I think is like the main downside of this approach. And the motivation for this is that the current payloads that you need to sign for Soroban is that it does not contain the address for which you're signing this payload. And in the current OS framework, it makes sense because it is implicitly tied to the address. So address is signed, but it is signed in a different part of the payload. But with the delegation, like you need to explicitly sign for the address that is a top level address that delegates everything. So basically, without that, this whole thing would be insecure. So that's kind of the annoying divergence between like the different credential types. I think while it is definitely a downside, it's probably not as big because it has one-to-one mapping to the credential type. Right. So if you do not support delegate credentials, you don't need to worry about this. If you do support delegate credentials, you don't need to worry about this. But the criteria for picking the right signature payload is very straightforward. Again, CAP has more context on this issue. Yeah, so I think it is more or less it at the high level. CAP also has a proposed simulation flow, which is kind of universal for any load that wants to use delegated accounts. So if G accounts support this, you can do this for G accounts, but then there are some custom accounts implementations around that also use delegated accounts, which I know there could be, like, OpenZeppelin have been working on something similar. And I know Tyler has experimented with this for a while. So, if you like, there's a lot of convenience and tooling here, well, also simplifying and optimizing the transactions. Right. We'll cap this real for yeah, we will get to cap century later, but probably answer is yes. Question silence. So any questions? Allows designers to sign G transactions. That's CAP 72 and not yet, but it is a step forward in that direction, right? If we ever allow designers to sign transactions, and G accounts with designers will also be able to do that. That's again CAP 72. We can talk about this a bit later. Yeah, it is definitely a step forward to more interoperability between G and C accounts in general. So I know that Lee had some concerns about CAP 71 specifically in terms of like, well, it's yet another protocol feature. And I do not disagree that it could partially result in simulation, but as I've mentioned before, I think doing this at the protocol level is very beneficial, especially if you go ahead with CAP 72. And it does not only like improve the EX, but it also simplifies the transactions, which is not something that simulation would allow us to solve. Okay, as you run no questions for CAP 71, please feel free to chime in the discussion thread if you come up with something. yeah, I think that let's go to CAP72 because I can see that folks are excited about it. So again, 71 is kind of what I think is a prerequisite to 72, just to make it kind of not hacky out of the box. So CAP72 is about, as I mentioned, contract signers for Stellar account, for G account. And motivation for this CAP, it's described in the original discussion as well, but basically, well, to allow you to do different things with existing G account, because G accounts still have quite a bit of adoption rate, and this allows to extend their functionality arbitrarily. It can be new ways to sign for operation. It may be a way to implement new policies and stuff like that. It is really very open-ended. I think there is a lot of demand for passkeys. It is a pretty hot topic, and an argument can be made that maybe you can support this natively as a built-in signer. This is not a part of CAP72, but I don't know, I'd like to gauge some interest. Maybe another discussion can be started if someone thinks strongly that has to be a feature on a G account now. Of course, if in the future we support signing for transactions with C account, this will become a non-issue because you will be able to do anything with the C signer that you can do today with a normal G account. So, well, yeah, I don't want to spend much time on this motivation here, but I think it is pretty significant factor, the ability to modify the G account. Really a lot of things to do with this. So what do we do for this? The first thing that we do is we add a new signer type that is stored in the account entry in a similar fashion as any other signer. And it is called delegated signer, which is basically how it connects to CAP71, right? It's also a delegation because unlike the cryptographic signers, for example, that exist for accounts now, they're just public keys. Delegated signer is a contract that defines its own auth logic with its own cryptography and stuff. Every signer has its own weight, in the same fashion as normal signers have weight. But the caveat for now, at least, is that delegated signers can only be used in the smart contract environment because those are contracts. You cannot run contracts outside of smart contract meters environment just yet. So unfortunately, you will not be able to use the signer to sign the whole transaction, but you can do anything in Thorban, and signing the transaction will work if we ever support signing the transaction with a C account as well. So basically, if we support running the contracts transaction validation time, which I'm not saying it's necessarily going to happen, but it's definitely something we are thinking about. Again, Bunsen, sorry about that. Okay, so besides that, what we do is that since modifications to the since operations with C accounts can only happen, but one notable use case we've been thinking about has something to do with various account recovery flows, right? We using passkey, so there are other custom logic to, for example, recover the account, right? This use case needs an ability to modify G accounts from Soroban. And we provide this ability with a new type of built-in contract, which I call this GAC, G account contract. And unlike Stellar Asset Contract stack, which has to be explicitly instantiated, GAC is implicitly exists for any G account on chain. You do not need to do anything to interact with it from Soroban. You will be able, just starting from a new protocol, to call contract functions on a G account. Just very convenient, and it is kind of low overhead solution in terms of storage. Okay, so that's kind of a high-level overview. Now let's go into a bit of detail. So in terms of the XDR changes, as I've mentioned, it's very straightforward. We just extend the existing signer set of signers for the G accounts, and we just allow to store them in the G account. They're not supported in some more exotic contexts, like some operations and stuff like that, but that's a minor detail. And then the G account interface as well, specified in the CAP, and it is still up to debate. The CAP, as it is, proposes to add an ability to add any type of address as a delegated signer, which might create some ambiguity, like if G account is a delegated signer of a G account, but it's like G account itself is a public key. So we have kind of the same identifiers that may be in two different contexts, and it may not cause some issues and confusion downstream. So it is still up to debate. Like if you decide to not go with delegated G accounts, contract interface may be simplified a bit to manage signers just based on the address type. So G signers would be always cryptographic signers, for example, and C accounts always delegated signers. It would slim down the interface a little bit. But anyways, the current proposal is just to have a pair of functions to modify a weight for a EDE 25 signer or remove it, then the same pair of functions to modify weight for delegated signer or remove it, and then two functions that just manipulate the weights of the account. It's not strictly necessary, but this seems like a logical thing to have if we provide the basic account management capabilities anyway. So just allow to modify the master weight and update the thresholds for the account. So this is just for completeness, not strictly necessary. So for the classic transactions, as I mentioned, the delegated signers will not be supported at the moment. So transactions that try to use them will be rejected, and there's not even a way to kind of provide a signature for a delegated signer. But for the smart contracts themselves, we extend the built-in functionalities that performs authentication for the G accounts. And this extension leverages CAP71, where we would call the functions defined there, which will enumerate all the delegated signers existing in the current context. And we will call this new delegate account of host function for them. And we'll obviously use the XDR format for the payload defined in CAP71. So this directly benefits from it. And another caveat is that account management operations that in this CAP are they must have a high signature threshold to match the semantics of the set options operation. So it is something new that we do. Previously, we always used medium threshold for all the Soroban operations to authorize G accounts. So that's a small change to use high threshold for the account management operation. And I guess the only somewhat tricky part about the implementation of the G account contract itself is that we kind of do something new for Soroban here. We had a way to manage classic entries from Soroban. Not just manage them, but add or remove new entries, which hasn't happened before, right? Before, the only thing we did with classic entries was we update the trust range balances of the account balances. Now with this CAP, we will also modify sub-entry count, this sub-entry count, which affects the base reserve of the account. And if we remove a signer, we also might need to remove a sponsorship from this signer. This is all like perfectly reasonable to do on the Soroban side. It is a bit of work to kind of properly maintain the invariance. But on the high level, yeah, I guess the main concern here is that account has to authorize its modification, and it obviously does that by authorizing the G account contract function itself. So on any call, as I said, you need to provide a signature that matches a high rate threshold, and besides like performing the modification as well, also authorizes modification of the account's reserve and sub-entries. The only difference between this and classic is really that you cannot create new sub-entries using some sponsorship, because there's not even a way of setting up sponsorship for Soroban. So if you want to manipulate a G account with GAC, you need to have enough base reserve. You cannot use someone else's sponsorship, which I think is generally fine. And if someone wants to sponsor a G account, they can do that by, for example, performing an XLM bundle with a G account modification or something like that. Yeah, so I've mentioned already that every G account function performs requires, and it will require a high signature threshold. And yeah, I think it is pretty much it for the high-level overview of the CAP. I think, yeah, I think I don't have much else to talk about, like from more details in the CAP, but I don't think there is anything too significant. And the main thing that, not the main thing, but at least one thing that I'm still not sure about is a final interface. Like what we do is delegate G account standards, but I think this can be taken offline, especially since Lee is not here and had some concerns about representing delegated standards and so on. Yeah. So any questions? Yeah, speaking of string keys, by the way, I do not think we will need string keys, like a new string key for this one. I hope at least. So you will just have a G account and it can have a C signer. So that's probably the direction you'll end up in. So know your account at the time. Yeah, any questions? Okay, I think don't see any questions for now. It's going pretty fast again. I would say, like, if anyone has any thoughts or comments, please feel free to chime in the respective camp discussions. And Matthias is typing something. I'll wait for a few more seconds. Okay, so quote from the CAP, this has a somewhat non-Soroban authorization being used to monitor the own balance of the account for hasn't been before. So why this is the case? This is the case because classic, when we create a new classic entry or sub-entry, such as an account signer, we need to reserve base reserve from the account that owns the entry. Base reserve being 0.5 XLM as of today, right? So it is not a strict withdrawal of the fee, right? We will not like in the fee event or anything for that rate. It just increases the event rate, thus reduces your spendable XLM balance on the account. It is just like we cannot bypass this mechanism, right? We are doing the same thing that we are doing on classic base reserve, and just doing it from Soroban now. And I guess so. The non-intuitive part about this is really that this hasn't happened before, but I feel like it's not super offensively counterintuitive, because when you authorize an account operation, you basically, it is like a high privilege operation anyway, and you acknowledge the consequences, and one of the consequences as well, your base reserve can be increased on the account, so you can spend less XLM now. It is the same as classic, no way around this. I looked into an alternative where like extra signers could be stored in the Soroban side, and then you would need to pay rent for them. It's not like it removes the fees magically, it just moves fees in a different direction. But ultimately, I'm not sure if the approach, the other approach, or is through signers and Soroban is worth it, because it creates some new interactions in classic Stellar that going to be kind of tricky to implement and maintain, and are generally much more invasive than what proposed in this CAP. But yeah, if anyone is curious, they may look up the history of the CAP, because it's the first version that was merged. All right, I think we have like 20 more minutes, so why not go through CAP 73 while we're at it. And CAP 73 really supports CAP 72 on one hand to allow C accounts to sign for the trust fund creation, but also in general it just closes the feature gap that has been there from the inception of Soroban, and I think some people are very well aware of it, and it happened, I guess, just in some flows that do not involve any custom auth or anything. And the issue is basically that when you're doing theoretic contract operations in Soroban, you cannot create new balances for the G account. And new balance being an account entry itself for the XLM token specifically, and a trust line for any other token. And it is like not completely blocking usage of SEC, right, for G accounts. You can ask the users to set up the trust line first. But there are contexts where you may want to do this programmatically. There is, of course, a CAP 72 context. You may want to use your C account logic to manage your trust lines. And it also helps to kind of bundling this with some programmatic operations, such as, for example, an example I saw recently from Tyler Week. With that, you would be able to, for example, create a new classic asset effectively and create a distribution account, transfer asset to the distribution account, like distribute later to the users, all in the same transaction, which is pretty convenient. So yeah, I guess there are convenience. There is convenience factors. There is a factor of really closing the feature gap, and a factor of being more compatible with C signers of G account with CAP72. That's the gist of the motivation. And the way it works is via two new functions for the store asset contract. These functions are change trust and has trust. And again, the exact interface is still a bit up to debate, but as it states now, the change trust function operates in the same fashion as the, I forgot the name of the operation in Classic. I think it's called change trust as well in Classic, the operation. And what it does is basically sets a trust line limit for a given address. If the limit is 0, then the trust line is removed. If the limit is non-zero, the trust line hasn't been there, then created. And of course, if it is there, it can be just modified. The question is whether we need to manage limit at all. I did some analysis among the trust lines that have been active during the last year. 98+% use limit, trust line limit over 1 to the power of 18, which basically represents infinity. But if anyone is aware of any use cases for limits that are low, please let us know, because we might get rid of it for the sake of simplicity, because yeah, it is not really obvious if it is necessary, and for this programmatic manipulation of trust lines, it's really likely that only binary modifications would be possible, because if you need a non-infinite trust line limit, you're doing something super specific, probably, and yeah, it seems kind of weird that you would know that the user wants to do that. It seems really unlikely. And another function, hasTrust, just checks if an address has a trust line, and the purpose of this function is really to make for better programmability of trust line management, because change trust operation requires authorization from the address that the trust line belongs to. And for example, you are performing a USDC transfer to a new address, right? And normally you would only need auth from the transfer source. But if you wanted to create a destination trust line, then you would also need auth from the destination as well. You cannot just unconditionally call change trust to make sure that the trust line exists. Maybe you could, but then, you know, you could make it so you don't need to require auth if the value is not verified. It is really something up to the further discussion, like how this interface looks like. But anyways, this is a current proposal. The hasTrust function really helps you check if you actually need to call change trust or not, and thus whether you need to require auth from the receiver of the balance or not, which is convenient if you wanted to call this from within a contract. Similarly to CAP72, this modifies base reserves, and again, in the same vein, we cannot avoid that because it's classic semantics. And we require authorization on the change trust operation in the same way of classic. So the base reserve modification is just yet another thing that you're authorizing by signing this, and it has the same downside or same thing about it going, that sponsorships are not available. So if you want to create a trust line, you need to have sufficient XLM balance for it. And for the XLM specifically, there are no trust lines, and instead you just create a new account. Then an XLM transfer is performed to a G address that does not exist yet, and this account will be funded with this newly transferred balance. The only caveat is that the minimum transfer amount here is 1 XLM, because that's the minimum balance that a G account may have. If the balance is less than 1 XLM, the operation will fail, as it does today. Well, it will fail with an new error. So, yeah, XLM is arguably much simpler because it does not require any and yeah, it is very simple in this sense. And yeah, I think that's pretty much it on the high level. That's a pretty simple cap. Yeah, it's only tricky part about it. It's really nailing down the interface, because yeah, we could make it much simpler if you went for like binary, either 0 or infinity trust. But we need some signal whether it is too restricted or not. Okay, question. In Classic, one of the reasons sponsorships were added was to prevent accounts created by wallets from being merged by Zans partly for the base reserve. Is that a concern for creating accounts and transfers of sponsorships? I am not sure I understand the question. Creating account on transfer, why would you, isn't that how it works for Classic as well? Like when you create an account, you XLM, so it's like an XLM transfer. Maybe you could go to this page. Yeah. I cannot hear you if you are talking. Nope, I cannot hear you. Oh no. Yeah, that's unfortunate. Yeah, we can discuss this async. I am still not sure I understand this. Maybe it is some bit of classic protocols that I'm not aware of. I haven't found out when preparing this cap. So technically thanks. Technically the trust line part and XLM part are kind of independent. I bundled them into the same cap because they really serve the same mission of like dealing with non-existent G account balances. So I felt like it makes sense to close this gap all at once and not just for a part of the site balances. But yeah, if we figure out that something is much harder to do or much easier to do, we could speed this up further. But given how simple it is, I would hope we could do both atomically. So yeah, that's three caps. I guess the only one thing to say for now is that we are still not sure which protocol will this go into if this gets through. So likely some of the caps will come a bit later, some may come sooner, so stay tuned for that. And yeah, please feel free to leave any feedback or suggestions in the cap discussion. Thanks everyone.